Welcome to my channel. Today we look at more examples on determining a cross product of vectors. And we had looked at the same thing. We looked at, in our previous video, we looked at how to get a cross product of vectors, but we used a different method. So today we'll be looking at the same thing, but we'll be using the method of determining the determinant of vectors. So if you're given vectors, can we get the determinant? So the determinant, we'll be using the method of obtaining the determinant to get the cross product of vectors. And of course, there's another method, an easier method that I'll be looking at. So in this video, we'll look at two methods of getting the cross product. So let's go to the first example, and the first example says that if this is vector A and this is vector B, find vector A cross vector B, and then find vector B cross vector A. And of course, this is easy. It's easy because once you obtain this, it becomes easy to get this by just multiplying by negative, as we saw in our previous video, that this vector is in the opposite direction of this vector. So once you have this, just multiply the result by negative, and then you have this. So let's go straight to part A. Part A, so we use the method of obtaining the determinant, I, J, K, and then it's A cross B. So I begin by listing the coefficients of vector A, which are 3, 2, 1. And then they're followed by vector B. The coefficients are 1, 2, 5. 1, 2, 5. So the way we get the determinant, the same way we're doing this, that it will be I times the determinant of the matrix left when I delete the row of I and the column of I. So when you delete the row of I and the column of I, the matrix that remains is 2, 1, 2, 5. 2, 1, 2, 5. That's what we see here. And then it will be negative J, and you know how the negative comes in. The negative is coming from, you see the position. The position, you take negative 1 raised to the position of the element. That is the position of the element, the row of the element, and the column of that element. Let me use N and M. Let me use N. Let me use N and M. Just use N. Let me use N and M. N and M. So for instance, this element I is in row 1. But this is plus. This is plus. Is it plus? Yeah, that's plus. The sign is plus. So if I have negative 1, and then this is the row of I, which is of course row 1, and this is the column of I, which is column 1. So this gives me 2. So the position, the sign here will be negative 1 raised to 2, and this will be positive 1. So that's why this one becomes positive. What about this? J. J here is in row 1 and is also in column 2. So if I raise that to negative 1, this is the same as negative 1 raised to 3, and the answer will be negative. So that's why you see this negative here. And This matrix is what remains when you delete the row of J and the column of J. So when you delete the row of J and the column of J, you're left with 3, 1, 1, 5. We come to this, is it plus or minus? Again, we can determine that. We take negative 1 raised to the row of K. K is in row 1 and is in column 3. So this is an even number. So it is negative 1 raised to an even number, which gives us positive. That's why this becomes positive. And what about this matrix? This is a matrix that remains when you delete the row of K and the column of K. When you delete the row of K and column of A, you're left with 3, 2, 1, 2. 3, 2, 1, 2. Now, so what then means? It means is that now we get the determinant of these matrices and multiply by I, determinant of this matrix multiplied by negative J, the determinant of this matrix multiplied by positive K. So let's just do that. The determinant of this matrix would be 10 minus 2, which is 8I. The determinant of this matrix would be 15 minus 1, which is 14, times negative J, so it's negative 14J. Then the determinant of this will be 6 minus 2, which is 4. 4 times K, that gives us 4K. So A cross B is 8I minus 14J plus 4K. In a similar way, you can determine B cross M. Or you can just do it the way I already said at the beginning, that to get B times cross A, just multiply this by negative. Because when you multiply this by negative, you have B cross A giving us negative 8I plus 14J, then minus 4K. We can do it that way. That looks easier and fast. But if you don't want that, you can still do it the same we did at M. Now, I said that I'll show you another easier way of finding the cross product. So the easier way that I used is this. So this is IJ. That's the same matrix that we had above. I've just brought it here. IJK 3, 2, 1, 1, 2, 5. Then I take these two columns, the column of I and the column of J, and add them here. So this column of I, column of J. And then you realize that we have 3 diagonals in blue. These 3 diagonals in blue running from top left to bottom right. We have those 3 diagonals. We multiply along these 3 diagonals as we add the results. For instance, this diagonal would be 10I. This other diagonal would be 1J. And this other diagonal would be 6K. And then you notice that we also have other 3 diagonals in red. They're running from top right to bottom left. So we multiply along these diagonals and subtract the results. That's why I've written here plus, plus, plus. That means along this diagonal we multiply and add. And I've written minus, 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 meaning that along these diagonals we subtract the result. So for instance, this would be 15J. So I subtract it. This would be 2I. I subtract it. And this will be 2K. I subtract it. Then collect like terms. 10I minus 2I gives me 8I. J minus 15J gives me negative 14J. 6K minus 2K gives me 4K. So you can see we have the same result. And this method to me appears simple. And that's why I said I'd show another simple way of finding the cross product. So B cross I already talked of the same, but you could use this method, or you could use the simple method that I've used, or you can just take the result for A cross B and multiply it by a negative, and you get this result. And of course, there's another way of doing it, which we had used in our previous example in the other video, where you expand just by expanding. So this cross up that, and then this cross this, and then this cross that. So if I take 3i cross I, I'd have 3i cross I, then plus 3i cross 2j, that gives me 3 times 2 will be 6. Then I cross j, 6i cross j. Then 3i cross 5k would have 3 times 5, which is 15, I cross k. That's what we see here. And then we come to this other one now, 2j cross I. That would be 2, then j cross I, 2j cross I. Then 2j cross 2j. 2 times 2 before j cross j. That's 4j cross j. Then 2j cross 5k. So 2 times 5 gives me 10 j cross k. 10 j cross k. I'm done with that. So I come to this k and use it to expand this. So k cross I, that's what I see here, then plus k cross 2j. That give me 2, then k cross j. Then if lastly, k cross 5k, that gives me 5k cross k. From there, we'll use our easier way of multiplying i's, j's, and k's, where we say we would have I, j, k, I, j, k. So we want to see I cross I, of course, that we know is 0. So this is 0 times 3, that gives us 0. What about I cross j? I cross j is in this direction. So the result will be positive k. Positive k. So this is positive k. So positive k times 6 gives us 6k. What about ik? Ik is this direction. So the result is negative j. Negative j. So negative j times 15, that gives negative 15 j. And then this ji, the result is negative k. So negative k times 2 is negative 2k. J cross j is 0. 0 times 4, that gives us 0. Jk is I. J cross k is I. So I times 10 is 10i. And then k cross I. K cross I is j. That's why you see the j here. And then this k cross j. K cross j is negative I. So negative I times this 2 gives us negative 2i. And then lastly, k cross k is 0. 0 times 5 is 0. So now we simplify by correct leg terms. Let me begin with the i's. I have 10i minus 2i, which is 8i. We go to the j's, 15j negative 15j plus j. That gives me negative 14j. Then coming to the k's, I have 6k minus 2k, which gives me 4k. So that's the other method you could use. We had looked at that method before. Let's go to another example. We want to do as many examples as possible so that it becomes clear to us. Now look at this question. The question says that find a non-zero unit vector W that is orthogonal or perpendicular to the plane of P, vector P, and vector Q. And this is what we stated when we began the definition of the cross product. And at that time, we said that if we have vector P and Q, and then this vector P cross Q is perpendicular to the plane of P and Q. And of course, we say that this cross product is perpendicular to both of these two vectors. We say that supposing this is P, vector P, and this is vector Q. And then our P cross Q is the vector perpendicular to P and perpendicular to Q at the same time. And so of course it should be perpendicular to the plane in which these two vectors are. So that becomes very easy for us to answer this question. We only need to be concerned about the word unit vector. But this other part we are already done with it. This other part means we need just to get the cross product of these two. And what about the unit vector? If I have vector u, how do we get a unit vector in the direction of u? So a unit vector in the direction of u is given by vector u over the magnitude of u. So in other words, what this means that for us to answer this question, we need to get P cross Q, which is the vector perpendicular to the plane, this plane. And then after that, we get the unit vector in this direction. So the unit vector in this direction will be given by this over the magnitude of this. So once we have this, we will have answered this question. So let's look at how I did it. So the first part is what I've already talked of. I've said that recall that P cross Q is orthogonal to P and Q. So we first find this, then the unit vector that we require will be given by this. And I'm using the simplest method to do this. So this is ijk. These are the coefficients for P, and these are the coefficients for Q. Let's just see that I put the correct ones. Let's just verify that I put the correct coefficients. For P, I have 1, 2, 1. 1, 2, 1. And for Q, I have 2, 5, 4. 2, 5, 4. Let's just verify that those are the coefficients I've used. 1, 2, 1. 1, 2, 1 for P. And 2, 4, 5 for Q. 2, 5, 4. 2, 5, 4. Let me see. Yes. 2, 5, 4. And then, as we said, we take these two columns and add them here. And then we multiply along this diagonal as we add the result and multiply along these other diagonals as we subtract the results. Doing that gives us that P cross Q is 3I minus 2J plus K. Let's just multiply. Maybe somebody may not be aware of how to multiply. Let's just again do it. This will be 8I. This will be 2J. This will be 5K. And then we're now subtracting this. This will be minus 4J. This will be minus 5I. And this will be minus 4K. Collect like terms. This 8I minus 5I giving us 3I. 2J minus 4J giving us negative 2J. 5K minus 4K giving us positive K. So we have the cross products. What we now need to get is the magnitude of these cross products. And of course, we now to get the magnitude of a vector to be 3 square plus negative 2 square plus 1 square. That's what you have. The square root of that gives us the magnitude, which is called 14. So we had already said that the required unit vector will be given by the cross products over the magnitude of the cross products. And when you do that, this is what you get. This is what we get. And this is the unit vector